Okay, good morning. Welcome to
AwesomeMath149.
AwesomeMath149. So we've been studying angles and parallel lines. And a couple times during the problems we've been working on, you used the idea that angles in a triangle add up to 180 degrees. And which is great. That's a good thing to know. We've never looked at that really carefully though, so I thought it'd be fun to talk about it because you showed me why you think it was true, and I liked your idea. So can you show me why you think angles in a triangle add up to 180?
Well,
Okay.
because if you draw like a right triangle, if we say this is a right angle, we don't know what these angles are, but if we draw another one, then we know that these angles, all of these are right angles, so that means 4 times 90 is 360.
Okay.
And we drew two of the same right triangle, so 360 divided by 2 is 180 degrees.
Ooh, that's really cool. So that's a great proof that angles in a right triangle add up to 180. I like that.
Yeah.
High five. That's a really great idea.
Yeah.
So I want to show you how you can do it for any triangle,
Okay.
not just a right triangle. So, believe it or not, it's the proof itself is not all that different than what we've been doing. So we're going to start with any triangle at all. Oops, of course I draw one that looks kind of like a right triangle, so I want to make it not be a right triangle, or an isosceles triangle. Why are triangles so hard to draw? Let's do this. There we go. Okay. So I'm going to call this angle A. And I'm going to call this angle B, and I'll call that angle C.
Yep.
Okay. And then the next thing I'm going to do is I'm going to draw a line parallel up here to this side of the triangle. All right? And then I'm just going to extend these lines in the triangle. Okay?
Yep.
All right, now, can you show me when I do this? Remember, this is parallel to this.
Yep.
What angles are going to be the same as B here?
Well, this one, if we call this angle 1 dash, then this angle is 1 dash, and then if we extend the line up here,
Yeah.
these two will also be that angle.
Okay, so this is B, that's B, and that's B.
Yeah.
So up here we have two B's, or not. Okay, very good. So I'm going to just write this as B right there.
Okay.
So that's angle C and that's angle B.
Yeah.
Okay. What angles are going to be the same as angle A when I extend angle A?
Well, if we call that 2 dashes, then this one will also be 2 dashes, then, well, if we extend it, I think that this one, this one.
Okay, great. So I'll call this also here angle A.
Yeah.
What do you notice now?
Well, I'm starting to notice that, well, there's a lot of angles up here.
Yeah.
And there's only one angle here that's uncovered.
Okay, ooh, yeah. Can you
And
see what
I
that...
think that these are both angle C.
Okay, so this is angle C up here, and that's angle A, and that's angle B.
Yep.
Okay. Do you notice anything else?
Well, it seems like the angles cover a whole circle.
Ah, interesting. What does that mean?
That means that these angles add up to 360.
Okay, and what angles do we have that add up to 360?
Well, we have 2 A's, 2 B's, and 2 C's. So we can divide everything by 2, and we get 1A, 1B, and 1C add up to 180.
Aha.
And then A, B, and C were the angles in the triangle.
Ha ha ha! So it wasn't when we had 2 of everything, they added up to 360, right?
Yep.
And so we can divide by 2. So did we want 2B or not 2B?
We wanted not to be.
Finally, we wanted not 2B. Ha ha ha. All right. Good work. Good work. So do you see why? It's just the parallel line rule that makes angles in a triangle add up to 180. But your proof is really good too for right triangles. That's actually not just really good, it's awesome.
Yeah.
Good work this morning, then.